Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to our video. In this occasion, I'm Jihan Ramadhani Rafiulna and our team, Nur Hasanah, Heri Mustafa, and Hendra Masfika would like to present our research about forecasting of JP-ASPRI personal accident insurance customer using the ARIMA model. Check it out.
Introduction. Insurance is an important part that needs to be planned to protect life in the future. Various types of insurance products that are already available and commonly used include insurance for education, motor vehicle, property, health, personal accident, critical illness, to life insurance. PT Jasa Raja Putra is one of the insurance companies that offers various types of insurance products according to the type of coverage. One of the product offered is personal accident insurance or JP-ASPRI, which is a type of insurance with protection provided for customer due to accident that may occur in the future. Record on the report of the insurance company PT Jasa Raja Putra Semarang branch, the number of personal accident insurance customer is very volatile every year. In 2019 and 2020, the number has greatly decreased due to the COVID-19 pandemic. Due to fluctuation in the number of already customers, a forecasting method is needed to make future plans for personal accident insurance product. In essence, the forecasting process will not always be 100% accurate because it will be influenced by factors in the future whose nature is uncertain. However, with the selection of the right method, it is hoped that it can provide a forecast with a small error rate. To predict the number of JP-ASPRI customers in the coming year, one method that is suitable to be used is the ARIMA method. The ARIMA method, are commonly referred to as the box-Jenkins time series method, is a method that has very good accuracy for short-term forecasting. While for forecasting with a fairly long period, the forecasting accuracy will be less good. Namely, the form of forecasting will tend to be flat or constant.
Based on previous research related to the ARIMA method by V. Selvakumar and others, which predict the number of motor vehicle insurance claims in the next 13 years, the suitable model is ARIMA 101. Another study by Karina Intan Permatasari and others obtained the ARIMA model 110, which is used to predict the number of newspaper sales in a newspaper company in Surakarta. There is also research by Biljana Petrevska in 2017 using the ARIMA method which predict the interest of foreign tourists visiting the Macedonian FYR with the best model obtained, namely ARIMA 111. Model in this research is the box-Jenkins model. The box-Jenkins model consists of several models, namely autoregressive or AR, moving average or MA, autoregressive moving average or ARMA, and autoregressive integrated moving average or AIMA. For autoregressive or AR model, show the predicted value of the dependent variable y, which is only a linear function of the previous actual y number. For moving average or MA model, state that the predicted value of the dependent variable y is only influenced by the residual value of the previous period. For autoregressive moving average or ARMA model is a combined model between the AR and MA models. And for autoregressive integrated moving average or ARIMA model, which contain PD key, is obtained where P is the level of AR, D is the level of the process of making the data stationary, and K is the level of MA. In this research, the steps of the study will elaborate the forecasting process using the box-Jenkins method can be carried out in 4 stages, namely model identification, model parameter estimation, diagnostic testing from the established model, and then forecasting with the best model. The first step taken in determining the ARIMA model is to identify the model. The requirement to identify the model is that the actual data owned is already stationary, both stationary in the average and variance. If the time series data is stationary, the next step is to identify the temporary model by determining the value using a correlogram, which include autocorrelation function or ACF and partial autocorrelation function or PACF. To estimate of the temporary ARIMA model can be obtained by looking at the ACF and PACF plot. After successfully obtaining a temporary ARIMA model, the next step is to estimate another model by testing the AR and MA parameters to obtain the best model. One way that can be done is by trial and error, which is to test several different parameters to become an ARIMA model and choose one of the models that have the smallest residual mean square value. After that, to perform a diagnostic test on the model, two stages must be carried out, namely the parameter significance test and the model suitability test. After that is forecasting process. Forecasting is an activity carried out to estimate a situation in the future. Forecasting is an attempt to predict future conditions through testing past circumstances. In a company, this forecasting activity can provide an overview of the state of the company in the future. The first step is identification model. Based on the data plot below, it shows that there is non-stationarity in the data in either the variance or the mean. Thus, it can be seen that the plot has increased or decreased the number of customers whose fluctuations are not constant every month. To create stationary data invariance, we use the Box-Stokes transformation. After the first transformation, the round value of the transformation result is 2. This indicates that the data from the first transformation still shows non-stationary data invariance. Furthermore, a second transformation is performed on the data of round value. The data resulting from the second transformation is 1. This indicates the data is stationary in the variance. After create stationary data invariance, the next step is the process of identifying the data that is stationary in the average. To create stationary data in average, we use the differencing method. The result of differencing obtained indicates that the data held is stationary in the average. Because the plot shows that fluctuations in the data have occurred at the center or horizontal values along the time axis. Because the data is stationary in both variance and mean, then the data is stationary. If the data obtained is stationary, then the next step is to identify the model. The model identification process is carried out by looking the ACF and PACF plots. In the ACF plot shown, there is a cutoff at leg 1, indicating the presence of an MA1. Then, in the PACF plot shown, there is a cutoff at leg 4, which indicates the presence of an AR4 in the temporary model. Previously, it was known that the data experienced differencing. Thus, the ARIMA model that will be formed is ARIMA P1 key. The next step is estimation parameter model ARIMA. To find the best model to be used in forecasting, all possible ARIMA model parameters can be tested. With P maximum is 5 and the maximum key is 5, then to form an ARIMA model P1 key, there are 36 possible models. Based on table 1, it can be seen that the ARIMA model 214 is the best model. Thus, the value of all parameters in the model is significant and has the smallest mean square residual value. The next step is diagnosis checking. The diagnostic test was carried out to verify the ARIMA model obtained and ensure that the model was worthy of being used as the best model in the study. The diagnostic test in ARIMA modeling consists two tests, which include a parameter significance test and a model suitability test. For test the significance of the parameter, based on table 3, it's found that the p-value of each parameter is less than 0.05. This indicates that all the parameters of the ARIMA model 214 are significant to the model. For the model suitability test is a test carried out to find out the estimated model has met the assumption that the residual or white noise are normally distributed. For residual test of white noise, based on table 4, the p-value of each leg is greater than 0.05. This indicates our residual value is white noise. And for residual test is normally distributed based on plot, it's performed that the p-value is more than alpha. This indicates that the residual are normally distributed.
Based on the three tests conducted to determine the feasibility of an ARIMA model, it's concluded that the ARIMA model 214 meets the requirement as the best model. The next step is forecasting. By using the ARIMA model 214, the number of JP-ASPRI personal accident insurance customers in the next 12 period can be seen in the table 5. The forecasting predicted number could provide an overview to the company so that it can be suggestion and input to the company to optimize their price to improve the company's achievement. Conclusion in this research divided by 3 points. ARIMA modeling that is suitable for use in research is non-seasonal ARIMA. The best ARIMA model that can be used to predict the number of JP-ASPRI personal accident insurance customers is the ARIMA model 214. And by using ICOMER model 214, forecasting result in the next 12 period experience fluctuation in the number of JP-ASPRI personal accident insurance customers that are uncertain every month. This is because the forecasting process is not only based on time, but there are other external factors found in the insurance company.
And these are some of the references I used in the research. That's all our video presentation. We hope all of you can enjoy the video. If you want to discuss more, please comment below. See you. Wassalamualaikum warahmatullahi wabarakatuh.